let me open with an observation, and that is that we have conversation. The presentations you made ranged from issues of brain structure and physiology to disease. And of course, President Obama mentions that range in the whole brain initiative, although it appears that the initial product of the brain initiative is to be more around structure and physiology, as I understand it anyway. What are the common ethical questions that we need to ask, or common ethical principles? Or do you imagine that because a scientist is working only on structure and physiology, that they have different ethical responsibilities than those working on either disease or behavior areas?
So I think this is already mentioned in the last panel, which is that the liver doesn't think, or maybe it does, it just can't talk. By virtue of having a brain, you have a memory. By virtue of having a memory, you have a personal narrative. And these are the things that are devastated by Alzheimer's. And we're trying to understand what goes wrong, and in order to do that, we need to go to the physiology, and we need to be able to develop these new neural techniques. And that makes it a much more challenging enterprise than helping the heart or the liver, all important for saving lives. But somehow when you start tinkering with the brain, people get a little bit more concerned, because it's really tinkering with who you are. And that's, I think, something that we're all grappling with.
So you don't imagine that dealing at the structure level obviates that responsibility to imagining the larger function of the brain? Saying, I'm just doing cellular physiology at that level.
No, not
Dr.
at all.
Koch, good.
Go ahead.
No, not at all. As one of the previous speakers emphasized, we have 3 levels of responsibility of science: to our own science and the science done in directly those we are responsible for, to our field, and to society at large. And as Terry said, the functional brain is the one that gives rise to sensation, to feelings, to pain and pleasure, and this is what people care about. This is their life. I mean, your active brain, not your inactive brain, not the structural brain, but your active brain is who you are. Everything you think, everything you desire, everything you want is your active brain. And so therefore, this is ultimately what it comes down to. And so there are a few ethical considerations that apply there that are different than if you study the brain or the liver.
Thank you for these presentations, which are extremely helpful. One of the things that I've been hearing a good bit about is the structure of the brain initiative itself, and thinking about whether or not it is a good scientific approach, that is, taking the bottom-up approach of starting with circuitry and mapping as opposed to a top-down approach, starting with theory and driving the theory, and a concern that while ideally you'd be able to do both, in the realities of limited funding, that starting from the bottom up limits the amount of funding you can have from the top down. So I was hoping you could comment a little bit about it, since you are all so deeply involved, about whether or not you think this is a scientific approach likely to help us with some of the larger phenomenons that we're really interested in addressing the brain.
The atoms of perception, the atoms of memory are neurons. And it turns out there may well be 1,000 or more different types of neurons. And we need to have a complete description of them. We need to know how many there are. We need to know, think about your brain as being 100 billion Lego blocks of 1,000 different types. And unlike Lego, which is universal, in other words, every building block fits onto every other building blocks, we know that the 2x2 blue stone only fits on the 3x5 green stone. And those rules are important for memory. And it looks like that many diseases are very specific to specific cell types. So what we need, we need a detailed cellular level resolution. It's something we don't have access to if you study the brain from the outside using EEG or fMRI or other such bulk tissue techniques. But at the same time, we also need theoretical we need theories, we need theoretical concepts to try to map this incredible heterogeneous networks that we have great difficulty conceptually dealing with. We need to marry it with appropriate tools from information theory, from mathematics, and from physics. But both things are happening right now. There's a very lively field of computational neuroscience. It's heavily involved in the Brain Initiative. The Brain Initiative had a bunch of theoreticians testify, so I think both things are going on. But the bulk of the funding is in the bottom-up one, because that's where the bulk of the expenses are, in these very expensive instruments, building them and building the next generation of instruments.
Could I add something? Just very briefly, to address Nina's question about whether this is the right approach. And I think that's a legitimate question, and it's been very actively debated. Our working group met over the summer, 48 consultants, and there are many approaches, and why take this one? So the penny dropped on our last meeting, which was about humans. And I was very impressed with the progress that's been made in deep brain stimulation, already mentioned, and its ability to be able to alleviate some of the symptoms of Parkinson's, depression. Steve Hyman was mentioning this. And the technology that's being used there is 30 years old. And the reason is that in order to be able to approve something by the FDA, it takes $100 million to put it into a human. And so they're using, as Kellen Mayberg put it, a cattle prod, which is like a huge finger with a millimeter wide thing. And you know, we can do so much better if we could improve just taking today's technology and be able to selectively stimulate particular pathways, particular types of neurons. I think there's a tremendous potential here, which goes beyond the pharmaceutical approach, which is one drug fits all, but rather to go in and selectively stimulate particular parts of the brain, particular pathways, and that's going to create a different approach, which has been called the electroceutical approach. So I think that having that knowledge of the circuitry will allow us to develop the tools that we need to be able to intervene in a way to help patients.
If I can add just a short additional comment is that we realize that funding is very scarce and so on, and I think we should utilize as many opportunities as we can. For example, in the case of European Commission, they have what's called Human Brain Project, large initiative all around Europe, and they're focusing on more of the simulation of a brain, and therefore they are going to focus more on theory side, modeling side, and so on. So there's a huge leadership activity now from OSTP, hoping to collaborate with European Commission and our endeavor together. So these are the other ways I think that we can perhaps manage your question.
Okay. Thanks very much. Dr. Koch, you dropped a couple of really interesting bombs that I can't resist following up on these. Okay. One is I'm quite familiar with the notion of reductionism with regard to consciousness. A romantic reductionist is a concept I've never heard before. I'd love to hear more about that. What do you mean by that? Second, the second issue is this. You mentioned sensation in a dish, okay? Yes, sentience in a dish. So one question is there a difference between electrical activity between neurons and what we would call pain or sensation? And is there a relationship between that and the sorts of sensations that come under the purview of ethics? In other words, what is the moral valence of free-floating electrical activity?
Okay, so there's this, as Amy mentioned Socrates, scio ne scio, I know that I don't know. So, but there are a few things we do know for sure about consciousness and the mind-body problem, which we have learned in Socrates. One thing, there's this intimate relationship between electrical activity in specific parts of our brain and specific conscious perception. We know this partly through neurosurgery, through DBS or other neurostimulating devices. You can stimulate particular parts of the brain, and you can evoke, depending when and the exact protocol, you can evoke specific memories or specific conscious perception. perception. And every day in the lab, we see this, that you can put people in a magnetic scanner and you can see when they have states of pain or pleasure or see or hear, particular parts of the brain are active. So ultimately, it is going to be bioelectrical activity of a yet to be determined unknown nature. People are fighting, you know, what's the exact nature of the physical signature of consciousness. But everybody agrees. I mean, every scientist or the philosopher that study this do agree. Ultimately, the substrate of your conscious sensation is biochemical, bioelectrical activity. So that raises the question, if we build networks, and these networks are large and complex and begin to be integrated, not just random, but begin to show integrated activity like waves and oscillation and synchrony and ignition, etc., that raises the question, does this network feel like something?
Yeah. Could I just because one of the things I think we would like to do as a bioethics commission is make sure that in order to help this science progress, it accurately states what it knows and what it doesn't know and what the potential is. And what you said is accurate, that the neural activity is the substrate of, you know, the brain is the substrate of the mind. That said, we still don't understand, and it may be a puzzle, it will in all likelihood be a puzzle that lasts for a long time, what the, you know, our language, you know, what our language adds to, and our, you know, our cognition adds to the circuitry that's going on in the brain. In other words, we're talking now, and we're communicating not through brain, I mean, our brains have things going on, but we're communicating through words. That's a mystery, since we are social animals. That's a mystery that will continue to be a mystery after the, you know, all the mapping is done. It may, I mean, we'd love to solve that mystery as well. So you look puzzled by what I've just said, but I'm not puzzled by what you just said. I think what you said is right.
Well, I'm only puzzled in as far as if you look at language and the parts of the brain that support language, they appear to be no different than the parts of the brain that support
Correct,
vision or anything else.
That's all
So
correct.
it's basically all the same stuff.
Correct, but that's a puzzle, isn't it? Because language is different than vision.
Yeah, but so is audition and so is smell.
Right.
I mean, these are all different
Absolutely.
capabilities of the same underlying tissue.
But our language distinguishes us from other
That's cool.
creatures. Our sight is poorer than a lot of other creatures. Our smell is poorer than a lot of creatures. And our language is incredibly well developed. And maybe there's another creature, you know, who speaks a language that we don't understand at all. Dolphins certainly. But what we know is that language matters a lot. And the language of pushing science forward and pushing ethical science forward is the medium that we communicate in. And the only reason I'm saying this is you began by saying quickly, you know, what we have to know what we don't know. I think it's really important to demystify what the great progress that's going to be going on and make sure we don't scare people into thinking we think we know what we don't know.
Terry, do you want to comment on that?
Yeah, you know, I really understand the issues you're raising, and again, this is an ongoing debate. But you know, the bottom-up view is you know, Christof's view, which is that somehow the activity arising from the patterns of connections in neurons gives rise to thoughts and language. But it's two-way. In other words, you have a thought, it's going to affect the molecules. And it's going to do that through mechanisms that we actually are beginning to understand, which is synaptic plasticity. So you know, in language, when I talk to you, it's activating part of your auditory system, which then indexes your language areas, which then is going to have permanent changes in your physical brain, which is going to allow you to remember something that you heard here today. So I'm just saying that we really have...
There's no disagreement about the physical substrate. If there's any disagreement among thinking people who think about this, it's about what we're now capable of explaining and are on the verge of explaining and what we're not. This doesn't affect at all the capacity and the value of this science to crack issues of Alzheimer's and Parkinson's and a lot of other diseases.
You're advocating for an intellectual humility as we move forward. Yeah, Dan?
Moving from the mind-body problem to another ethical question, I heard Dr. Sejnowski talking about the use of non-human primates, and as want to flag that as an important ethical and policy issue, particularly as you're probably aware, quite recently due to an IOM report and an NIH panel, the use of chimpanzees has been almost effectively banned for federal funding. So the question for you and for the rest is, how important will the use of non-human primates be in this sort of research? And then secondly, are you worried about these sorts of trends at the federal level? In particular, will it push this kind of research into the private sector? Is that a good or a bad thing? What are the consequences of that as a policy?
So I was very concerned about the NIH policy, and I understand it. There's a lot of other strategic issues involved here. But I can say that without being able to have access with the tools and techniques that are being developed that cannot be used, we cannot do genetic experiments on humans. But if we can't do them in non-human primates, then there are going to be questions that will not be able to answer, actually getting to the very issues that were raised here. And so I think it's incredibly important that we identify those questions. It's not just for any question. There are some that the mouse are perfectly good for answering, and others for which the fly is perfectly good for answering. But there are some for which we're not going to have any answers at all unless we can have access to these very, very valuable species. And I think part of the backlash was that perhaps the ethical considerations about using chimps weren't properly prepared, and therefore that they couldn't justify some of the experiments that were being done. I don't know. I'm just saying that now is the time for us to properly prepare. And I really do think that I devoted all of my time to this because of the fact that I think this one issue is so important.
Thank you. Thank you very much for your presentations. I mean, the premise that we're considering today is that incorporation of ethical principles and thinking about ethics into neuroscience research would enable us to be able to do better. And each of you have provided examples of what your institutions are doing. The question for each of you is the following. What are your observations so far? Has this incorporation of ethical principles and thinking about that, has it changed in any practical way? Can you give specific examples how it has changed the research or enhanced it, or you think it would enhance it in your institutions?
Yeah, I can give you one very concrete example. So we thought a lot about so as I mentioned before, we have those brain atlases out there. So in 6 individual, we've done 1,000 microarray each in 1,000 different locations in these brains. So it's a lot of information. We've thought a lot about the issue of could these individuals be identified, and would there be adverse consequences for their living next of kin? And so therefore, for example, we've not put the genomic information. We've not put sequence information online. Now, we have made it available for a few select researchers who've asked us specifically, and we have research protocols there. So that's one concrete example where these considerations have directly effect. And we had endless discussion about this issue within the Institute and with our outside advisors board. In fact, we're now starting an ELSI program because as we go forward, we want to sort of preempt these issues and think about them before we actually start doing the science.
Christof gave another example with the question you're asking about the Petri dish, which is really important for people to come to terms with. When is sentience? That it's a scientific and an ethical question combined. It's a very, very helpful, I think, when scientists are aware of.
So from the Kavli Foundation, we do not have our own operating research institutes. So all our research institutes are embedded within a large university setting. And therefore, we rely on those universities' capacity to manage ethical issues. What we're observing is that every university seems to have different level of attentiveness in what bioethics means. And I'm really looking forward to this commission to really provide some guideline that is standardized so then every university can perhaps practice these issues as more standardized manner as they can.
If you had that information as a funder, would you contemplate a requirement in proposals and in performance?
So we haven't yet, but I would like to also mention one of the reasons why we haven't. The Kavli Foundation is very cognizant about supporting research in very fundamental basic research. And in our minds, restricting or fearing scientists surely doesn't encourage creativity and innovative thinking. And so we try our best not to come up with what they cannot do. You need to abide this rule, you need to, and so on and so forth. With that philosophy, we had not been engaged in that way. At least that's our thought for the moment.
So you imagine ethics being a potential restriction in this case?
You know, I myself have
been that's not, I want to take that back. That's not a fair question.
Yeah,
that's
okay,
yeah. Terrence, would you?
So the Salk Institute is a basic research institute, about half devoted to neuroscience. I've already mentioned that we have one of the world's leading centers for studying monkey vision. Recently, I have started collaborating with a group at MGH which records from human beings that have been implanted with electrodes in the course of studying epilepsy in their brains that are intractable to drugs. And I have to say, this has completely changed my whole view of research, because as you can imagine, you know, doing an experiment on a human being that's talking to you is very different from putting electrodes into a monkey. And it's really caused me to rethink a lot of what I'm doing, and a lot of the soul searching that, in fact, is beginning to happen. It has already happened with, in fact, Christof was one of the pioneers in recording from humans. He famously discovered the Jennifer Aniston cell. And, sorry, Christof. But we now routinely record from humans for 2 weeks straight from hundreds of areas of the brain, depth electrodes. And I have to say that scientifically, this is a gold mine. This is like, and this is, there are 200 centers where this is being done. There's only 20 where they're being studied scientifically. And in our report, we said this is a real opportunity to be able to create teams of people in hospitals, neurosurgeons, scientists, physiologists who understand exactly what questions could be asked and answered. And I really think this is going to revolutionize this opportunity to actually have access to the human brain. Not only our neuroscientific knowledge, but a lot of the ethical issues that were brought up here. So I think that we should prepare you know, what if we do, not just the Jennifer Aniston cell, but we do find some, in fact, okay, here, this is one example, just a concrete example. So, this was not the Jennifer Aniston, it was a Halle Berry cell, right, in the temporal lobe, and it responded not just to pictures of Halle Berry in many different poses and different images and different configurations, but to her name, you know, the name in English. So that suggests this is not an image. It's not it's not a visual cell. It's a conceptual Halle Berry cell. So this is really getting to something, you know, semantics, to meaning.
I originally had exactly the question that was raised about the animals, the monkeys, and I was thinking about the monkeys on the one hand, and then the issues that Dr. Gutman raised about human exceptionalism and language, and how what we know about the substrate won't necessarily tell us much about the mysteries of life. So I guess where I want to go now is someplace we haven't gone at all. It's about the mysteries of life. Because why do we care about the monkeys? You know, I think it has something to do with our concern about cruelty to animals. But why do we care about humans on whom this very same experiments might be performed? It's not just because we care about cruelty, it's also because we care about controlling or interfering with the brain because it's the substrate of the mind. And furthermore, we care about experimenting with humans because we care about the mind, about spirit, about possibly religious values, and interfering with the brain somehow evokes concerns that may go to our religions. We're a public commission. We don't have sectarian principles that we are guided by, but we know that the community, the public, worries about these religious kinds of values. So I'm wondering whether a kind of a nice sort of summary of what's at issue with the monkeys is that, one, we care about cruelty to animals. Two, we care about how the experiments on animals might lead to inhumane, mind-controlling experience on human beings, whether that's true or not. I think people worry about that. And then three, there are concerns about mind and spirit that affect people's religious values, and might be some concerns here about ultimately doing something to undermine our religious beliefs and values. So I just wanted the panel to comment on that sort of taxonomy, and also to directly address these questions about people's religious concerns and how they affect, for example, willingness to donate their brains for science, for scientific purposes.
And that actually be our last set of questions for you.
So as scientists, I think we ought to be concerned with reducing the suffering of all conscious creatures, whether it's human or non-humans, because we're all nature's children, we're all in this. And so therefore, I think what you said is correct. We need to be concerned with animal cruelty, that we don't do injustice to the animals. They are, including mice and monkeys, they're all conscious creatures. They all share some of the pains and pleasures of life. They don't have insight, they don't have self-consciousness. That seems to be something associated with higher primates, particularly us, but they are sentient, and so I think we should conduct all of our experiments accordingly. I give a lot of public talks on the subject of consciousness, and yes, you're right. People are afraid that somehow neuroscience will leach the meaning out of their religious sensibilities and their spirituality. I beg to differ. That's why I call myself a romantic reductionist. I think you can have a variety of ethical and spiritual beliefs while still believing that ultimately consciousness and you said the secrets of life is tied to the brain, and it's our mission as scientists to try to communicate the wonders of this to the general public, including the fact that you can be a spiritual person and still do all this neuroscientific research.
Thank you.
So first of all, I want to thank you for raising this issue, because it is something that is incredibly important for the public. And so my mother was a very religious person. She went to church every day. And, you know, when I told her what I did, you know, she would question, you know, how is this related to, you know, to God? And I have to say, I didn't really have a good answer for her. She's no longer here. But I do have to say that I agree with Christof that you can be a scientist and be spiritual and understand that there's something we don't understand that is very deeply mysterious about not just the human brain, but the brains of all creatures. So I think we have to be humble in the face of this mystery.
I just want to say something in thanks to you all, and to on behalf of the Bioethics Commission. We see our role both in helping move the neuroscience in general, as well as the Brain Initiative forward, in a number of ways, and I'll just mention two because time is short. One is we all want to do the right thing in our professional lives, and so it's obviously important to move neuroscience forward in an ethically correct way. But the other, which is, if you will, extremely practical, is that if we can work together and integrate ethics into neuroscience, as you exemplify, by the way, in a thoughtful way, but we need to make sure all institutions do that, we can facilitate the intellectual freedom and progress of the science. There's nothing that grinds an enterprise, a scientific enterprise is no exception to this, to a halt, than an egregious, unethical public, and it will get a lot of attention. And I just want to thank you all for both your support of this Brain Initiative, but you're taking this really seriously, and I can assure you we'll work with you and make sure we come up with the kind of recommendations that are deserving of recognizing that good science and good ethics go together.
And that is our last word. Let us thank our panelists.
Thank you.
Thank you so much.